What's up, guys? This is Billy here from Kenosis Energy Solutions, and today we're gonna be talking about this Growatt inverter. The model of this inverter is the SPH6000 6000TL BL-US. That's a mouthful. There you can see all the specs. Take a look at them. I'm gonna be more focused on how to navigate this display right here, because I did a video on another channel just touching that display and it got 10,000 views. Hopefully I can get more views than that in this video right here. So yeah, I'm gonna give a brief review of the setup right here. This right here is an auto transformer. So this guy, what it lets me do is input the energy from the grid on one side right here. The black cables are energy, is the 240 from the grid. We are in Puerto Rico, so we use 120 240 split phase. So this inverter does not output that kind of voltage. It just outputs 240. So in order to get a neutral and split phase, you must install this auto transformer right here. You can see the diagram right there. This is more clear. You can see how to connect the grid on the two slots in the middle, and then you have the output of the inverter of the EPS. EPS output of the inverter stands for emergency power supply, and it gives you up to 3,600 watts of continuous energy. When the grid comes out, that EPS activates, and I can have energy from my trusty lead acid industrial battery bank right here. I have a little tool right here I was working with, and this is the manual of the inverter. A little bit old. The inverter's at least 2 years old. I'm gonna just take this metal plate right here so you can see what we have inside. It's a little bit, yeah, I have some stuff right here, a little bit messy, but yeah, here I have double cables just to reach the amps that I'm drawing and charging to the battery. And you can see that it's bolted together. They are 2-volt cells, making a 48-volt configuration. The little LED light right there is giving me an indicator of how the liquid of the battery is behaving. If it goes down, the LED will come off, and I know that I must water the battery. Yeah, that's my battery right there. I think it's a 44 kilowatt hour battery bank, so it's a good battery bank. But yeah, it requires maintenance. You need to water it once in a while, like monthly or so, depending on how much you use it and charge it. Yeah, this is my setup right here. I do not have solar. I have not had it for the 2 years that this has been installed, but you can input solar to this device in this connection box right here, and I'm planning to do that. Just run it through here and plug it up to an inverter once I get my solar panels. But yeah, we're gonna take a look at the display right here. I'm gonna go back to the battery voltage first. So here's the battery voltage right now. The battery is charging. You can see that brick shows up. You have a little symbol DC AC, that's the inverter, and it's going down charging the battery. We have like half of the battery charged or so, it says the inverter, but we're gonna get to that later. This is the voltage. Now we're gonna go, this is the watts, the power that's being charged, sent to the battery. You have 3,600 watts, so it's basically a maximum capacity right now charging the battery. It's roughly, at that voltage, it's outputting roughly 67 DC amps at 53.9 volts. We have the PV voltage. We have no voltage right now. This will be 1 and 2. So you have two charge controllers on this inverter. But we don't have solar right now. So that's at 0, the PV power. This will be the PV, the photovoltaic power, or PV power, 0. This is the grid voltage and frequency here in Puerto Rico. 249. It's supposed to be clean at 240. But yeah, sometimes it gets a little bit higher. And at 60 hertz, so it's where it's supposed to be. This is the power, total power that's is being sent from the grid right now to the battery. So it's quite high. You can see this will be the apparent power and the real power. So always the apparent power is going to be higher because you have a power factor that is yeah, limiting the conversion from DC to AC. But it's good power factor right there. This is the EPS output. So this will be the voltage. If the grid goes out, it will show the voltage that the EPS is sending to this auto transformer right here. And then since it's an auto transformer, it's gonna flip and it's gonna give me power from the EPS instead of from the grid. So like I said, the EPS is connected there, and this is the output. We have an output breaker. This is the output that goes directly to my manual 100 amp transfer switch. Right there. This is the output of the whole system. So once the grid comes off, it changes. The inverter activates the EPS output, detects voltage, and it switches quickly. This happens in a matter of less than a second. I'm talking milliseconds right now. So yeah, that's the EPS voltage and frequency. I'm gonna show you later when I turn off the grid breaker. And this will be the EPS power. It's a 0 right now. We're not using the EPS, like I said. EPS power. We have the per load, means the percentage of the maximum capacity of the inverter that is being used on the EPS load. So if it can output 3,600 watts, if I would be drawing 1,800 watts, that would be 50%, and so it would be like that. And this is the total power being sent to the grid. It always shows something, but I'm not sending anything to the grid because I do not have this inverter exporting right now. But it's a feature that it has. And this is the total. This will be the total AC output since the system was installed. So 392.9 kilowatt hours. Total energy right there. This is the total energy from the PV side that I have generated today. So it's 0. I don't have PV. And the total energy that it has generated since the system was installed. 2.5. I don't know how, because I've never plugged PV modules to this inverter. But hey, it's welcome. It's free energy. And right here we have the total charge that has been sent to the battery today. It's a 12.1. Like I said, this is a 45 kilowatt hour battery. So we would like to get that to, let's say, 40 to get a maximum charge. Here is the total charge that since the system was installed, total charge sent to the battery, total energy. And you have 1,582.7 kilowatt hours. That's a lot of power that I've sent to charge the battery. And this is the total discharge daily. So today, 0.2. I have not discharged the battery much today. I just did a quick test earlier. This is the total daily, a total discharge since the system was installed. The A means since the system was installed. So 104.1 kilowatt hours have been discharged. That does not make sense to me because I have charged 1,582, but only discharged this much, 104. So that means that the inverter charge sends energy to the battery, even though the battery has not been discharged. That's a feature that this inverter, I do not like from this inverter, because if you let the AC charge on, it will charge the battery daily in the time that you set up. We're gonna see that later, but it will charge the battery and run it dry. So that's a feature that I do not like of this inverter. It cannot track like the status of the charge of the battery. This is the total AC that I have sent today. It says today, that means that's what the D means, but I have not consumed 239.9 kilowatt hours. That's not the power that I've sent from the AC output, so that means that the inverter is wrong there. That's too much, way too much. And this is the total energy that I have used through the AC output since the system was installed. So that does not make sense. 392 and today 239. You can see that it's a wrong calculation. And here you can see the date and the time. You can set that up. It's the serial number of the inverter, and here is the model of the inverter and the firmware version that it has right now. Yeah, that's what we have in the main display. If you long press the OK button, you're gonna see, if you let it go, you're gonna see all the parameters from the inverter. Here you go with the basic parameters. You press OK. You have language, that's fairly easy. System time, easy. And this is the rated voltage. We're gonna enter here just to see. System, it's rated for 240. This is the voltage here in Puerto Rico. You can set it to 208 and 230, if I'm not mistaken. We're not gonna change that right now. Here you can see the lead acid constant voltage is what I call it, because once you set this voltage, the system is gonna try to get the battery up to that voltage. I have it quite high right now because I have not charged the battery like in 2 weeks, and I wanted to get a higher charge than I would usually, and I cannot equalize here. That's a feature that this inverter does not have. It does not have equalization mode for the battery. That's another thing that I don't like about it. So I just put it in the highest voltage I can. This battery should charge and absorb at 58.0 volts. So yeah, I put it at 59.2. Hopefully it gets a much stronger charge than it would normally. But yeah, it's constant voltage. It will not gradually increase the voltage. And you have constant charge. This is the amps that it will try to send to the battery, but like I said, it limits to 3,600 for the charge of the battery. So it does not get to 80. It gets around to 66, 67, almost 70 amps, DC amps. We're gonna escape right here. We have the low voltage, the voltage at which the inverter will shut off. We have set to 44. That is quite low. You can send that higher if you want to. Language, it's pretty self-explanatory. We're back to system. We're back to language. Yeah, that's for the basic parameters. Then you can see off-grid settings. So you can see the voltage that will send it off-grid, the frequency that it will output in off-grid mode, and if it's enabled or not. You want that enabled in case you lose power from the grid. That's good. We're gonna go to priority. Here's where you can set the priority of your system. If it's battery, if you want to prioritize the load, you can set that to low too. If you choose battery and press OK, it will send you to AC charge. I have it enabled right now. You can disable it, and if you press enter, you can see that it will ask you for a password, and that will be 1 enter 1 enter 1 enter 1 enter. That is the password right there. So you can enable, set OK. I'm gonna switch hands right here. Enable that, and you wanna go set up the time that it will charge the battery. I have it set indefinitely, like from 12 a.m. I mean, to 11:59. So I'm setting it to charge indefinitely, basically for the day. And if I leave it like that, it would charge the battery like every day for those hours. So I cannot leave that like that. I have to change and disable the AC charging at the end of the day today, so it will not run my battery dry. You can change that however you want. The stop SOC is gonna stop the charge. I have set to 100%. The power rate is the power rate that it would charge the battery, also 100% for me, because this battery can take up to, let's say, 90 DC amps if you make the calculation. And here you're gonna save your changes. You're gonna double press OK, and you're gonna go back to battery first. You can press escape and go to the other settings. I mean, escape twice. Or you can set the grid first as priority too. Here is the mode change. You can change the mode that it will sense. Exactly, you can change the mode that it can sense the current on the CT. We have it set for CTs, but we do not have the CTs installed right now. The CTs that I have right here is just for this Emporia meter. This little power meter that I have set up so we can sense. It's an ugly installation, but we can talk about that in another video. So here we're back to setting the battery, the type. You can choose between lead acid and lithium battery. I have a lead acid battery, so we're gonna leave it. We're gonna press escape. If you wanted to save the changes, you can press OK. Export limit, it's gonna let you choose if you want to export. I am not exporting right now. The power rate, maximum power rate that you want to export to the grid. That's the percentage of the inverter that it will export, the maximum capacity of the inverter. And yep, you can go back. And lastly, the backup mode, you can set this up, disable or enable it. And you can, this is basically a backup mode that it will set the inverter and prioritize the charge of the battery. So you will always have a fully charged battery. But this mode disables itself in 1 week. So you will have to keep coming here and enabling the backup mode. So I don't like that. I have a nasty cut right there. I just took a look at it. And here you can set the inverter for the default settings. Yeah, that's basically it for the display. That's the only settings that you get. Like I said, what I don't like about this inverter is that I have to keep shutting down the AC charge, and if I forget to shut it off, it will keep running my battery dry. You can see that it has liquid right now, but it will dry it. If I leave it charging, it will dry the battery. Yeah, if you have any questions about this setup right here, feel free to ask me any questions on the comments down below. And if you like this video and you find it useful, please give it a like, comment, and subscribe, because I'm gonna keep making videos like this. I can make them in Spanish if we have Spanish speaking people. I just think that English is the most common language, so I'm trying to make them in English. Yeah, see you later. Remember, Canasi's Energy Solutions for all your needs here in Puerto Rico.